We're reaching the limits of what we can launch from Earth. Every rocket has a fairing. Every fairing has a size limit. But what if the biggest things humanity builds never have to leave Earth at all? What if we build them directly in space? Welcome to the idea of space factories, orbital construction sites where robots can manufacture structures far larger than anything we've ever launched. A space factory is exactly what it sounds like. A manufacturing facility in orbit that uses robotics, autonomous systems, and sometimes 3D printing to build hardware in space instead of on Earth. Imagine a workshop floating in microgravity. No gravity, no atmospheric drag, no launch constraints. It's a place where raw materials arrive in small packages and enormous structures are assembled piece by piece. Think of it as off-world manufacturing. Robot arms assembling trusses, free-flying printers, laying down beams, machines unfolding solar arrays longer than football fields. All in zero-G. This isn't sci-fi. It's the foundation of the next era of space engineering. The largest payload fairings can only fit structures a few meters across, but future science missions want kilometer-scale telescopes, giant antennas, and huge solar collectors. These can only be built in space. Microgravity allows materials to grow perfectly. No sagging, bending, or convection currents. That means ultra-pure crystals, defect-free semiconductors, exotic alloys. These could revolutionize electronics back on Earth. Some materials literally cannot form under Earth gravity, but they form beautifully in orbit. Why build a rigid, heavy structure that needs to survive a violent rocket launch, when you can build a lighter and smarter one directly in orbit? Space factories build lightweight trusses and flexible architectures that no rocket could safely launch. If we want space solar power, orbital data, farms, radiation-shielded habitats, interplanetary shipyards, then we need the ability to build big things in space, not just small satellites. Robots have to be able to assemble beams, weld joints, and repair themselves without human hands. NASA's OSAM programs and private companies like VAST and Kinemetrics are pioneering robotic assembly in orbit. We need printers that can extrude metals, polymers, or composites in microgravity. Concepts like SpiderFab propose printing entire trusses in orbit, meters or even kilometers long. Future factories may operate from private space stations, VAST's Haven stations, Starlab Orbital Reef. These platforms could host robots, storage bays, and maintenance systems. Structures built in space need new materials that are radiation-resistant, thermally stable, ultra-light, easy to manufacture in microgravity. This includes advanced alloys, carbon composites, and even in-space grown crystals. Factories need feedstock. Initially, we'll launch raw materials from Earth, but long-term, we may mine asteroids for metals and water, turning the solar system into a supply chain. Kilometer-scale telescopes, to image exoplanets directly. Massive solar power satellites. Giant data center, in supercooling for free. Deep space ships, assembled in orbit, never touching Earth. Infrastructure materials, for the Moon and Mars. Humanity has always been defined by how it builds things. Tools, cities, machines, megastructures. Space factories are the next step. They break the limits set by gravity and rockets, unlocking structures bigger and more ambitious than anything we've ever imagined. The future of construction is off-world.